This video is about the split data operator. This operator partitions example sets into two or more example sets. It's often used to make training data to build predictive models and test data to determine if the models are correct and thereby avoid the curse of overfitting. We'll look at the partitions parameter, the sampling type parameter and the use local random seed parameter. Slightly more complicated process than normal to illustrate various features of the split data operator. This is a sub-process which makes 100 examples. The top output contains labelled data. This is a multiply operator that simply passes the data unchanged through so we can observe it in the output. A copy is also passed to the split data operator, which partitions it into two example sets, and we can examine these in the output. The bottom output is similar data but with no label, and again you can examine that in its original form and in the form after it's been processed by the split data operator. Let's run the process. Now I've created a special view to allow the results, the process and the parameters all to be seen in one simple view. So what we'll start with is this tab here. This is the original data, and for orientation where my mouse is now is the output that this corresponds to. So there are 100 examples, and if we look at the statistics view we see there's a label, future customer, there are 47 yes, 53 no, it's binominal. There's an ID just to help us keep track of what's going on, and there are three attributes: age, gender and payment method. I guess what this is trying to do is make a prediction about future customer status based on these attributes. If I now go to the split data 2 tab, this again for orientation is this row here, is this line here, and this has 70 examples in it, but it looks very similar to the original. If I click on the split data operator and edit the partitions parameter, we can see that what's happening is that the split data operator is splitting the data into two partitions. The first has 0.7 as a relative size and the second has 0.3. So the rule is these have to sum to 1, so essentially 70% of the data is being output on the top output there. The remaining 30% of the data is going to the bottom output. Now you can add more than one, you can have several partitions here. The rule is that they should add up to 1. Turns out I discovered it doesn't matter, it actually normalizes it to 1, but keep life simple, make sure you add up to 1. Okay, so that covers the partitions parameter. And just to look at the second output, this should contain 30 examples. Sure enough, we see 30 there. Now let's look at the sampling type parameter. There are three options: stratified, shuffled and linear. Stratified sampling is the one I'm using here. This tries to keep the class balance the same in the partitions. We can check that. If I get to the original example set, there were 47% out of 100 were yes, 53% no. If I go to this, 70 examples, statistics view, 33 out of 70 were yes, 37 out of 70 were no. If I use my calculator, 33 over 70 is 47%, and that's 53%. And that compares with the proportion in the original data, and I could do the same exercise for the smaller partition. Now it's important sometimes to have a balanced class distribution in your test and training data, and The stratified sampling essentially ensures that happens. The alternative to it is shuffled sampling. I'm going to run this again now with shuffled sampling. So again, this is the original data, 100 examples with 4753, but if I look at the split data in this situation, it's subtly different. It's not a very big effect, but 32 out of 70 is 46%. Now arguably that's trivially tiny and probably well within the possibility of just random fluctuation, but it might get important if your data is quite small, and perhaps if you had a lot of classes with a small number of members in each class, you might end up with very strange class proportions, and that might make your modelling process less accurate. But anyway, either way, you need to be aware of it just so that you can take it into account when you're building your models. The next sampling type I'll look at is linear sampling. Now this just takes the examples in order. So if I rerun the test, now again we have 70 examples in the split data, but if I look at the statistics now, I'm getting a very different result. As you can see, 17 out of 70 is about 24%, and if I go to the smaller partition, in fact there are no examples. Slight tautology there. And the reason for this is that if I go back to the original, turns out I'd sorted it by future customer. So if I scroll down, you'll see that at ID number 53 there's the last no, ID 54 is yes. What that means is that the linear sampling simply just works down these, taking the first 70 to build this partition, and the remaining 30, so clearly it's going to get it hopelessly wrong if you want the class imbalance to be the same. Now this could happen if your data has been sorted for some reason. Now we'll look at the local random seed parameter. You'll notice I'm using this and I'm setting it to the value 1. So if I go back to stratified sampling and change that to 2 and run the process again, now we see that, just notice the IDs that have appeared in this partition. 1, 3, 4, 5, 6. If I run this again with the original 1 value, some of the IDs are different. Essentially all the local random seed does is to set the seed for the random number generator to be a specific value. If I check that off, then it uses a system value. So typically most people use this because it means you can reproduce very easily results, but if you want true randomness you can actually put a macro in there if you need to. So now let's look at the bottom part of this process. So let's just run the process again. So now the data looks like this. Now what I did is I changed future customer to be a regular attribute. This process is the same as the one above. It splits the data into a 70-30% partition. But because there's no label, I'm expecting the stratified sampling actually not to work. Running it shows in fact that it does work. So I might regard that as a feature here. Just be aware that the stratified sampling, strictly speaking, should not work properly because there is no label for the process, the operator rather, for the operator to get hold of. But anyway, I changed that to shuffled sampling. Everything works as before. And I guess it will similarly work with linear sampling. So in conclusion, I'll simply run the process one more time and flick between the original data with a label, then to the 70% partition, which is that one there, and then finally to the 30%.